Lights on.
Hi, I'm Luke and that's a tutorial for the Audio Reactive FX asset pack on the Unreal Engine Marketplace. When you download the asset pack, you get a project, or you can import the contents of that project into your own projects. What you get then is this Audio Reactive FX folder. If you open it up, you have a few subfolders, one for blueprints, that only contains one blueprint here. Then a maps folder which contains this demo map, so for your final build you can delete that. A materials folder which contains all the materials used here. They are all procedural, so no textures here, just materials and material functions. The materials here are a few materials from my other pack that is called Modular Procedural Materials. In that other pack there are way more materials and material functions. I also have a tutorial video for that explains how I structured all the materials and how everything works. So if you want to know how that works, you can watch that other video. I will link that in the description. Then we have a mesh folder which contains one head and some basic meshes that are used for the effects. So most of the effects can have other meshes, so you should be able to easily replace them because they use procedural materials. That makes it easy to replace the meshes. And then the most important folder is the Niagara folder. It contains all the Niagara systems and emitters. So most of the systems are based on one emitter each. I'll just quickly show how that works. So if you don't know, the emitter is kind of the blueprint for the particle system. So if you go to your system and click that button here, you go to the emitter, and here is the base setup for your system. What you can then do in your system is you can add new modules on top of that, and you can turn on and off all modules as you want. The only thing you cannot do is delete modules here that exist in the emitter. That's forbidden, but you can turn it off if you don't need them here. So that's a good starting point for new particle systems, to just take one of the emitters and add stuff on top of that, or change things a little bit or replace them. Okay. And then we have the modules folder, which contains module scripts for the Niagara systems. Let's take one here as an example. So the best way to know how those modules work is just if you go to one of the Niagara systems that does something you like, that you want to replicate. For instance here, the spectrum analysis. Just go into the system that has that functionality and look up all the modules here. In that case, it's NMS spectrum, and there you can set a few values to define your spectrum, but I will talk about that later when I talk about that specific asset here. Okay, let's start with the assets. The first one here is the audio analysis tool that captures audio to be used with all the other assets. So you can take it from that blueprint folder here, drag it onto your map, and it will start capturing all audio that's heard in-game. That means automatically all microphones that are attached, everything that's attached to your auxiliary input on the PC port, and all in-game audio. If you don't want to capture everything, you go to that asset here, and that has an audio capture component. And that uses the new audio system of the engine, and here you can set a base submix. That's a submix is basically something like an audio channel. So every audio asset in game will route to some submix. If no submix is defined, all route to the same invisible master submix, and that's the same that happens here. That just uses the master submix because nothing is selected. But you can set up a mixer and multiple channels, and then you can route different audio into different submixes, and then you can tell this capture component here to just capture audio from one submix. You also have an audio here. You can, where is that? Here. You can set the sound here. So if you have an audio, a WAV file, or any other file that you want just to play back, you can set that here, and then that will be captured. Okay, then let's start with the actual audio reactive assets. The first one here is that spectrum electric, which is a radial spectrum analyzer. I select that here. What you can set here is the number of spectrum repetitions. So in that case we have 6 repetitions. If I set that to 1, you can see here is the base and the spectrum goes around. So you should use even numbers because every second spectrum is mirrored to make it seamless. But I set it back to 6. Then you can define the number of circles around. So that is at the moment set to 4. Let me see if I can, yeah. And you also have something called the ring distance. If you set that, you see the actual rings are divided in space. But I had it with 0. And then there is this jitter parameter that gives it that kind of electric look. But you can turn that off and then it's straight. Okay, what else is important for this one? You also have a rotation. The base rotation is, the basic rotation of the thing, 0 to 1. I had it at 0.25 because I had this layout with 6 spectrum repetitions. Rotation speed, let's set that to 1. Okay, that's pretty fast. Let's do it a little bit slower. Okay, and then there are a few parameters that are reoccurring in most of the other assets as well, and so I will only explain them once. The first of them is the audio spectrum, of course. The second one is here the audio threshold. You can use the threshold to cancel low noise. So if you set that to 0.3, you see now it only reacts when there is more noise going on. So when I speak up, then it reacts, otherwise, wait a second, I also turn the jitter off, then you can, so now when I'm silent, it's doing nothing. When I remove the audio threshold, when I'm silent now, it's still doing a little bit. So if you want all the effects to be completely disabled when there is no music or no sound going on, then use that audio threshold, set it to 0.1 or 0.2, Then what else is important? Yeah, glow, minimum and maximum, that's self-explanatory. The gradient as well, you can set the color. That means color at low volume, color at high volume. I think it's visible pretty well here. So where we have a high amplitude, there is the, where is that? Always select something else. So high volume is here, low volume is black. Then of course you can set the width of the line, the basic width, and then how much the audio spectrum contributes to the width. So if I set that to, let's say 100, you see then it's doing that. But I can also set that to be inverted to have a base width and subtract it when volume is loud. But okay. Then the radius, then also contribution of spectrum to radius, the number of points. So if you reduce that to, let's say 3, then you have a triangle. So that gives you also a very interesting look if you want to have it like that. Okay, that's it for this asset. The next one is quite similar. It's also a radial spectrum analyzer, but in this case it uses a ribbon tube and not a plain ribbon. So if you can see that it's actually a 3D geometry. But for the parameters it's pretty much the same. Maybe this is interesting. For many of the assets you also have this spectrum range start and end. So that means which part of the spectrum to take. So if you have start at 0 and 1 at end, you take the full spectrum, which is defined in your audio spectrum. That means 0 would be 110 and 1 would be 10,000 in that case. And if you change that here, where is it? So that only takes the lower half, or a little bit more than the lower half of the spectrum as information, because usually there is more going on in the bass than in the heights. Okay, then the next one here is called layered noise mesh. That is producing meshes with procedural material on it. So what you can do here is you can have different shapes. That is a very low poly sphere. You can have wait a second, let's rotate that. Okay, wrong axis. Okay, that's a torus object. Then a pyramid, a cube, and a high poly sphere. But the material that's applied to that is procedural, so you can basically add every mesh you want. You would simply go here, add or duplicate one of those mesh renderers and set another material here. Where is that? Override materials here, and that is this procedural material. You would just select a different mesh here. And this reacts to audio in two ways. The first one is it makes the material glow with audio, and the second one is it increases the spawn rate with higher volume. And base glow is glow from audio, and base react is spawning more particle meshes with the audio. So if I increase that, okay, let's reduce it. Now you don't see any effect anymore, but if I change that back, you see as I speak the intensity increases. And here again you have a gradient, and yeah, there are other properties like minimum size of the meshes, so they start in the middle and expand to the outside, and the material also has some animation on it. And yeah, that's basically it. You can set properties of the material here in the particle editor. Let's see. Yeah, that's just different properties of the material. So you can just play around with all those values and just take it when you like how it looks. Okay, then here that one is called spectrum tunnel, and you can see that creates a tunnel of meshes. Again, you can select different types of mesh. Let's do that. So we have spheres, torus mesh, the pyramid. So it's basically, it's the same meshes as in the other object. But again here, they have only a very simple material applied, that where the color and the emissive amount can be set from Niagara, so you can also easily exchange the mesh here. And what else can you do here? You can of course change the gradient that is used here for coloring, and set the intensity, set the amount of objects in the ring, set the speed of the whole thing and the lifetime. And I think that's it basically. The next one is similar to that, but it has some kind of vortex going on. The next effect here is the spectrum flow, that creates particles in a line at one point, and depending on the audio it sets the color and the size at spawn of the particle. So, and it flows in one direction, so you can set the lifetime of the particles and also the shapes. You can again use all those shapes that are contained, and you can set the gradient and how many particles are in the line. Yeah, and you can also repeat the spectrum here. Spectrum repeat. So if I set that to 1, again we have the base here and the heights here. And let's set that to 4, then you have that. 8, you have that. You see it just repeats the spectrum, and again every second is mirrored. Okay, then here this one is called function plane. That is basically a grid of particles. Again, you can use all the base meshes as particles, and they have again a very simple material that just changes the color, and it's basically a grid but with sine functions applied to that, and you see that wavy movement here. It has quite a lot of parameters here. So let's see what, yeah, okay. And you can, so it has this layers X, Y, bottom and top. So that is the same now, but if you change that, you see it has, now in the bottom it has more objects than in the top, and that's for the width and for the depth. So if let's change that, yeah, so you can produce quite crazy stuff with that, but you have to play around a little bit to get to something. But that's very useful for background. So if you have it in the background and you enable that wave feature here, then it gives you quite a nice look. Okay, here are a lot of parameters to define the wave function, and again you can easily just go into that and replace the particle mesh by any object you want to. Just if you want to also change the color, then you just need to add a particle color node to your particle to your material, or you can add dynamic parameters and do that. Let me show that. So here is a dynamic parameter node. So if you go to the material and override material, if you go to the material, and so here is dynamic parameter that can be controlled from Nagra. You can have up to 4 of those things here. If you want to have 4, you need to copy that and then set the parameter index to 0, 1, 2, 3. And then we have particle color here, so you can use that. So in that case, that has index 1, that's 0. And they become visible here. So you can just add any value here to control those parameters. Okay, then here we have the expanding torus. That is again what that creates objects, and they go from small to big in one direction. And again, the most important thing here is the material parameter. So if I open that up, where is that? So you can always just create your own objects, add those dynamic material parameters to your materials, and then just simply replace that here. So here, for instance, that particle has a spectrum amplitude value that is generated from this module here. You can reuse that. And here, for instance, is a curve atlas module that does a lookup from the curve atlas and in return creates a sampled color property in the particle. So you can easily hook that up to other things. Okay, the next one is this psychedelic looking head thing. This one is at the moment not audio reactive. That might change in the future when I get time to add that. That is also using a procedural material, so you can exchange the mesh here as well. I just recommend that you use a mesh that doesn't have too many hard edges, because that would make it look not so good with that material, and also it shouldn't have too much detail, because in that case then it just starts looking fuzzy. But here you can see there are multiple face meshes stacked inside of each other, and the material has a kind of a dissolve effect here, and here you can see into the inside. Okay, and the next one is the mandala, and that also has all the base meshes here, and okay, that reacts right like crazy. It's probably set too fast. Wave speed audio, let's reduce that. Okay, so you can see one thing is the material. So the material glows with the audio, and then you also have the movement. You can have wave from audio, but also increase of wave speed by audio, which is the effect that you see here. Again, it's very easy to just use other meshes for that. And I think the most important thing here is that this one has a module for mandala, spawn, and location. So you can use that to, it's similar to a grid spawn and location thing, but just with that mandala layout. Okay, and it has, okay, not that many parameters, but still quite a lot, because the next few, those are tentacle assets. So here you have tentacles that are defined by sign functions, and those are quite complicated. So they have a lot of parameters here. So the audio reaction in that case is the materials react to audio. You have this glow going on. Then you can see the animation speed reacts to audio, and you can also have the width of the object or the size reacting to audio. And I guess also the gradient moves, so you also are able to have an influence on the gradient move speed by audio. And as you can see, they retract and grow out again. I enabled that as kind of default animation to show it, but you can turn that off and then just, where is that, growth? So growth animation, let's turn that off. Now it's always like that, and you can then manually edit that to grow out somewhere. And by the way, all those parameters can be animated in the sequencer. So, okay, and here again, you can exchange the meshes that are used. And I just, in that case here, I need to explain a little bit how that works. So, for the, you have a number of tentacle layers. and then you have a number of tentacles per layer, and then you have a tentacle multiplier by layer. So let me show that. And then you have values for offset in this case in the up direction, and the radius to the outside, and each of these values have a per layer and per particle value where you can change that. So it's a huge mathematical function basically. So okay, here tentacle count, tentacle layers, and tentacle multi. Let's try that. And then you have tentacle points, which means the number of points along the tentacle thing. So here we have it with meshes, and the next one is with actual ribbons, but the core principle is the same. So, and I just want to show how that works. I want spectrum to speed now. I want to turn off the grow animation. Okay, good. And then I need to make it a little bit thinner. Okay, and then I add a second layer, and here I can have offset per layer. So if I set that to, let's say, 200, then you see that second layer that is outside is now offset by that amount. And if you have 3 layers, then the next layer would be offset even more. And let's search for layer here. Offset per layer, radius per layer, okay. And rotation per layer. So let's do 3. And okay, that. Okay, that's the layer, and then we have the multi-feature tentacle multi. I use 3 again, and then I have a spread here. Okay, that's not enough. Okay. And then I want to have a twist. Whoops, that's too much. Okay. Okay, the spread is in one direction. The twist is does like that double helix, or in that case triple helix stuff. Okay, that's that. And yeah, there are a lot of more parameters here that you can play around with. If I would go over all of those, that would need another video on its own, but you can just play around with that. And also look into the asset, and there you can see what modules are used, and you get to know what they do, and then you can also reuse them for other things. Okay, and then we have more tentacles, but this time they follow a spline. So where is the spline? Here. So there is one spline, and the tentacle follows the spline, and it has a mirror function to simply mirrors in the x-axis. Okay, and again, you can set the gradient of the material. Of course, you can also add another material if you want that. And it also has this growth thingy going on, so let's enable that animation. Oops. So that way it's pretty easy to make tentacles growing out of something. Again, that's can be animated via the sequencer. Okay, and it also has this movement going on. Where is that? It's called the spiral. Okay, now it has only the material animation and the spiral is turned off, but I can also increase that. That's basically a sine wave. Okay, and in the end we have some patterns here. I just added that because I had them laying around. They do not react to audio, but I used them for wall decoration. So there you have different kinds of patterns that are all particles. You can just scale them as you want and change the number of elements and how the animations work on that, so they make nice fillers in between other more interesting elements. Okay, that's it for now. I hope you enjoyed that video and also that asset pack, and see you soon. Bye.